The association of mankind with the ocean dates back to the mythical past. Human sphere of action and its interaction with the ocean for effective exploration and sustainable utilization has resulted in the emergence of multidisciplinary areas of ocean technology. Recognizing the importance of these emerging areas, National Institute of Ocean Technology, NIOT, an autonomous institute under the Ministry of Earth Sciences, Government of India, was conceived and started as the technical arm of the erstwhile Department of Ocean Development in November 1993. Picturesque campus of NIOT at Pallikaranai, Chennai, accommodates different laboratories, administrative offices and other facilities. The major technology development programs undertaken by various research groups of NIOT: Research and Development Programs, Freshwater and Energy from Oceans, Deep Sea Technology and Ocean Mining, Coastal and Environmental Engineering, Marine Sensors and Systems, Ocean Electronics, Ocean Acoustics, Submersibles and Gas Hydrates, Marine Biotechnology, Offshore Structures. Operational Programs: Ocean Observation Systems Vessel Management Cell. Rapid urbanization and population explosion and over-exploitation of groundwater resources are all increasing water demand. The mismatch between increasing water demand and decline in water availability due to over-exploitation and climate change is the most critical resource issue for policymakers. Desalination, which is the conversion of seawater to potable water through various physical and chemical methods, has emerged as a potential solution to India's and the world's looming water crisis. Conventional desalination process, reverse osmosis, is the most commonly used membrane process in the industry. High power consumption and the disposal of the concentrated brine are two of the major drawbacks of the process, and LTTD process is less power intensive, environmentally friendly, with advantage of minimum maintenance. Low temperature thermal desalination (LTTD) is one process that uses the availability of a temperature gradient between two water bodies or flows to evaporate the warmer water at low pressures and condense the resultant vapor with the colder water to obtain fresh water. The main components of the LTTD plant are the evaporation chamber, the condenser, pumps and pipelines to draw warm and cold water, and a vacuum pump to maintain the plant at subatmospheric pressures. National Institute of Ocean Technology (NIOT) has demonstrated LTTD technology using difference in ocean temperatures and established plants of various capacities. One such plant was successfully established in Kavaratti, the capital of Union Territory Lakshadweep. The advantage of the technology is that it can be implemented even with a low temperature gradient of about 8 to 10 degrees Celsius between the two water bodies. The Kavaratti desalination plant, with a freshwater capacity of 1 lakh litres per day, was established in May 2005. The plant has been running continuously ever since, fulfilling the needs of the 10,000-strong local community for over 4 years. Subsequent to the commencement of the plant and water supply for drinking water needs, there has been a significant drop in the incidence of waterborne diseases. The freshwater production at Minicoil commenced on 4th March 2011. The performance of the plant is quite encouraging. The seabed bathymetry near the Minicoil island was such that 400-meter water depth was available at about 600 meters from the shore. Temperature gradient of 18 degrees Celsius was utilized. High-density polyethylene HDPE pipes of 630 mm diameter and 700 meters long were deployed to draw cold water from a depth of about 400 meters. The seawater pumps inside the partitioned sump supply warm and cold water to the plant on the land. The salinity of the fresh water produced was reduced from 35,000 ppm of the seawater to 350 ppm, whereas the permissible limit for drinking water is 2000 ppm. Establishing desalination in islands and the challenges. Process. The deep sea cold water at a temperature of 12 degrees Celsius obtained from a depth of 400 meters is brought to intake sump located at water depth of 5 meters. The surface warm water at a temperature of 28 degrees Celsius is directly taken into sump. Pumps located in the sump transport both warm and cold water through the pipelines. A bridge is constructed to support the pipelines and also to connect the shore to the sump and plant. In the plant, the warm water is evaporated in flash chamber at a vacuum of 27 millibar absolute and condensed using the cold water. The main components of island-based LTTD plant are marine structure, deep sea cold water pipe, plant. Marine structure. The islands are generally made of coral with a lagoon on the western side and proximity of deep water on eastern side. The plant is located on the eastern side of the island. The design and construction of marine structure is a challenging task due to prevalent ocean wave and current climate near these islands and subsequent lack of any heavy lifting and moving equipment or facilities for heavy work. The technical challenges in design and construction of structure are construction of concrete sump weighing 300 metric tons cast in lagoon and its movement to the site in floating condition through a distance of 10 kilometers, traversing the shallow channel in the lagoon. Construction of the connecting bridge that crosses the intertidal region, the breaker, and extends up to a depth of 5 meters. The design and casting of the bridge piers and the deck to take care of the construction in high wave activity region is a particularly challenging task. Deep sea cold water pipe. The Institute has specialized in the design and construction of deep sea submarine pipelines from water depth of 400 meters to 5 meters in environment of high ocean currents and waves. Deep sea cold water pipes were designed and deployed in 3 islands of Lakshadweep. The cold and warm water is pumped to plant using submersible pumps designed and optimized for water level variations of ocean tides. Plant. All the process components required for generation of fresh water were designed and executed by the Institute. The plant is fully automated and equipped with necessary instruments for continuous monitoring and minimal intervention. NIOT achievements in LTTD technology. Commissioned plants. 2011. Land-based 100 meter cube per day plant in Minicoil. 2009. Condenser reject-based 250 meter cube per day plant at NCTPS, Chennai. 2007. Barge-mounted 1000 meter cube per day plant off Chennai coast. 2005. Land-based 100 meter cube per day plant in Kavaratti. Not resting on past laurels, NIOT has taken up the projects under the LTTD program in islands and mainland. Land-based 100 meter cube per day plant in Agatti Island of Lakshadweep that is nearing completion. Land-based 100 meter cube per day plants in Androth, Amini, Shetlat, Kadmat, Kalpeni and Kiltan Islands of Union Territory Lakshadweep. Condenser reject-based plant at TTPS Tuticorin. NIOT strives to fulfill the nation's needs by means of ocean technology for fresh water, food, weather forecast, environmental monitoring and protection, sustainable harvesting of living and non-living ocean resources.